Okay, guys, today we're going to be doing solving absolute value inequalities. So again, I'll talk about the primer of what we have to worry about. We are going to be using what we learned in absolute value equations and coupling it with the compound inequalities that we had, which were, of course, and or. And meaning we must overlap. Okay, there has to be an overlap somewhere. And or means there doesn't need to be. Okay, we can have anything less than this and anything greater than that, or anything greater than that. So my trick, which I said, is when deciding which compound inequality to use, we want to take the time, get the absolute value on the left-hand side of the equation, and set equal or set with the inequality on the right-hand side. I want to back out anything that might have been impacting this. So if there was a multiplied by -3 on the outside, I would have divided by -3 in order to flip the inequality. But once I've moved everything to the opposite side, anything that's not the absolute value to the opposite side, now I'm going to look at the absolute value and read this sign. This is a less than sign. Whenever it's a less than, it means I can't be more than this many units from the center, okay? Or in this case, from 0. So my trick is I'm going to read this as a less than sign, and this is going to be a connected conjunction graph. If I've isolated this absolute value, okay, I've moved everything to the opposite side, and now my absolute value has a greater than. So that means we need to be further than 3 units from 0 or from the middle, okay? Then what we're going to use is we're going to read this as the absolute value is greater than. We're going to get a disjunction, so a broken graph with things being greater than a certain value, and then on the flip side, on the mirror side, we're going to have things being less than a certain value. Okay, so we're having mirror images around the center. Okay, so if the center is a less than, everything's going to be connected around it. If the center is a greater, everything is going to be away from the middle. Okay, so we're going to isolate the absolute value. What we're going to do, just like we did with the equations, is we're going to solve for the positive case. We're going to solve for the opposite case with a twist. So the absolute value here is isolated. There's nothing on the outside. It's the absolute value of the expression x minus 7. If there were anything between here, like a +4, I'd have to subtract it to the other side before I got to work. But this is all by itself. So we're going to say there's a positive case, or what's going to happen on the positive side of the number line, and then a flip, a mirror image in the number line here. So what's going to happen on this side? All right, so we're going to set everything in the middle. X minus 7 is greater than 2, and we're going to solve that case. Now, this is a greater than, so I'm going to use the word or. Okay, then we're going to take what's in the middle, x minus 7. We're going to flip this inequality, and we're going to change the sign. So we're going to solve for the mirror image on this side of the number line. So realize the greater than is heading in this direction, and the less than needs to be heading in that direction, the mirror image, okay? Now, I know this looks a little confusing in this line of work. I can't write in this app right now, but you would add 7 to both sides, add 7 here, add 7 there, and this is going to cancel, and you're going to get x is greater than 9. Okay, that's going to be your first one on the positive side, and here's 9. 9 is not a value we want, but we want any value greater than that, so everything in this direction. On this side, the second one, x minus 7, we would add 7 to both sides. Excuse me, there's a typo there. We would be adding 7 to both sides. So adding 7 to the -2. This would cancel, and -2 plus 7 is 5. So here we've got x is less than 5. So from here down, not including 5, and like we said, it was greater than, it was more than a certain distance away from the middle, and the middle here is going to be 7. That's where it gives us a 0. 7 minus 7 is 0. So I need to be more than 2 away from it on this side and more than 2 away from it on that side, and we want to maintain that distance. So it's less than 5 or greater than 9. Okay, now I'm going to just tweak this a little bit. Again, I have an isolated absolute value. I just changed the sign inside, but I'm going to now do the absolute value of x plus 7 is less than 3. So this means we can be no more than 3 units from that middle. Okay, no more than 3 units from that middle. And an and statement is going to be one of those connected graphs. And you can already see going forward, the graph is going to be that connected bar. Okay, so when the absolute value is all isolated by itself, we've moved everything over to the opposite. We can read this and say, this is the absolute value of x plus 7, which is less than 3. And is going to be the compound inequality that we're going to use. So we're going to take everything from here and set it to the positive case. Okay, so x plus 7 is less than 3. We would subtract 7 on both sides, subtract 7 from the positive 7, subtract 7 from the positive 3, and this is going to simplify to x is less than negative 4. So that would be an open circle line heading this way forever. Now on the opposite side, we already said less than, so there's the and statement. Now we're going to take what was inside, x plus 7. We don't change that, but now we flip the inequality. So this goes from less than to greater, and we change the sign. So we're doing the mirror image on the negative side of the number line. Okay, so if the first one was x is less than negative 4, we're going to have something heading back in this direction as its mirror image. Okay, now we'll subtract 7 from both sides, subtract 7 from 7, subtract 7 from negative 3. This cancels to give us x, and negative 3 and negative 7 gives me negative 10. So x is greater than negative 10. So open circle at negative 10, line extending this way forever. So those two inequalities overlap from negative 10 to negative 4, not including negative 10 or negative 4, but just every value in between. And you can see that the 0, what would give you a 0 in here would be negative 7. So negative 7 plus 7 is 0. So negative 7 is in the middle of this graph. It wants all values that are 3 units away or less from the middle. Okay, and that's where this graph is going to look like a and statement or a conjunction. Now, both of those examples were the absolute value was already isolated. Let me take a look at a quick example. I didn't get too intricate because I couldn't draw in this, but let's pretend that the example we were looking at was negative 2 times the absolute value of x plus 5 is greater than negative 4. Now, the way it's written is a greater than, so you would think a disjunction, but it's not isolated yet. So negative 2 needs to be taken care of. Now, normally, if these were parentheses, we would distribute over them, but we can't distribute over an absolute value. They behave a lot like parentheses, but not exactly. So we cannot distribute over an absolute value. So what we're going to do is we're going to divide it out. I'm going to divide both sides of the inequality by negative 2. Negative 2 times negative 2 will cancel and just give us a absolute value of negative 5. Negative 4 divided by negative 2 will give us a positive 2. And anytime you divide an inequality by a negative, the inequality must change. So it's going to go from a greater than to a less than. Okay, now that this is isolated, the absolute value of x minus 5 is less than and is going to be my conjunction. Okay, I can be no more than 2 units away from the middle of this function. Okay, so we'll solve for the positive case. So x minus 5 can be less than positive 2, and x minus 5 has got to be greater than negative 2. So we've got to flip and solve for the opposite because we're looking for the mirror image. So an inequality heading in the opposite direction as this one. All right, so now on both of these, we're going to add 5 to get the x by itself. Negative 5 plus 5 is just x, and 2 plus 5 is going to be 7. So I've got x is less than 7, open circle at 7, line extending in this direction. On this side, we would add 5 to the negative 5, and that just gives us x. Add 5 to negative 2, and that gives us 3. So x is greater than 3. That would be an open circle at 3 and a line heading in that direction. Again, the value that gives us a 0 inside is 5. 5 minus 5 is 0, and that is the middle of this function. Okay, 5 is the middle, and we can be no more than 2 in this direction and no more than 2 in that direction. Okay, so this is what we're going to be working on today. We are going to be in IXL L3. We're just going to be solving and then putting the inequality in. Now, one thing that we can say here, I'm going to jump to the other. Can I jump to the other side of this graph? One of the things that we can do here with a conjunction, realize we can always write it in a different form. So this conjunction, it's an and statement, and it goes from 3. It'll be less than x, which is also less than 7. That's an alternate way to write this expression here of x is less than 7 and x is greater than 3. I can write it connected as an implied and statement. Okay, so 3 is less than x, which is less than 7. So IXL L3 is just doing the solving and then typing something like this in. And IXL 4, you have to do the solving, but really they want the graph itself. Okay, guys, I'll post some videos on myself doing the IXL in a few minutes. Okay.